Some mathematician is telling me that there's a new planet, so-and-so coordinates in the sky. What is this stuff? I'm exaggerating. The Frenchman sent his findings to the observatory in Berlin. And the Berlin types said, what's this? A new planet? If I turn my telescope so many degrees that way and so many degrees, I will find a new planet? Son of a b****. There it was. They discovered a planet predicted by the law of gravity. And that planet they called Neptune. That's right. Neptune was predicted.
In the summer of 1989, human curiosity leapt across nearly 5 billion kilometers of cold, dark space to reach a world unlike any other. Neptune, windswept, storm-lashed, and more distant than any other planet in our solar system, waited at the edge of the unknown. After a 12-year odyssey that had already transformed our view of Jupiter, Saturn, and Uranus, NASA's Voyager-2 spacecraft drew near. What it revealed, storms the size of Earth, winds faster than anywhere else in the solar system, would redefine our understanding of planetary atmospheres and spark a fresh fascination with the mysterious blue giant. Before Voyager-2's flyby, Neptune was little more than a pale azure dot in even the most powerful telescopes. Its distance from the Sun, nearly 30 times farther than Earth, shrouded its secrets behind a veil of methane clouds and icy winds. But as Voyager-2 closed in, its cameras and instruments began transmitting a torrent of data back to Earth, beaming across the vastness of space at the speed of light. Among the spacecraft's most dramatic discoveries was a colossal, swirling storm, a feature scientists would soon dub the Great Dark Spot. The first close-up images of Neptune revealed an atmosphere alive with motion. Dominating the southern hemisphere, the Great Dark Spot loomed as a dark, oval-shaped scar against the planet's luminous blue clouds. Stretching nearly 13,000 kilometers across, roughly the diameter of Earth, this enigmatic feature immediately drew comparisons to Jupiter's Great Red Spot. But the Great Dark Spot was more mysterious still. It was darker, more sharply defined, and surrounded by even more turbulent winds. Voyager-2's instruments measured wind speeds racing around the Great Dark Spot at over 2,100 kilometers per hour, making Neptune the windiest planet in the solar system by far. These winds, moving faster than the speed of sound on Earth, created jet streams that circled the storm and helped maintain its shape. Scientists were astonished. How could such furious weather exist so far from the Sun, where sunlight is barely 1,000th as strong as on Earth? The answer, at least in part, lay in Voyager-2's detailed observations of the storm's structure. The spacecraft's cameras peered through Neptune's upper cloud layers, revealing that the Great Dark Spot was not a permanent feature etched into the planet's atmosphere, but a dynamic and ever-changing vortex. High-altitude clouds of methane ice streaked across the storm's edges, their brilliant white color standing out in stark contrast to the dark, swirling core below. These methane clouds, suspended high in the thin Neptunian atmosphere, provided a clue to the storm's composition and the forces at work within it. Analysis of the data showed that the Great Dark Spot was a massive anticyclonic storm, a high-pressure system similar in some ways to hurricanes on Earth, but on a vastly larger scale. The methane ice clouds formed as rising currents of gas cooled and condensed, creating the bright, wispy features that outlined the storm's perimeter. Beneath them, the darker vortex was a churning mass of hydrogen, helium, and trace hydrocarbons, all caught up in Neptune's extreme winds. Yet, perhaps the most surprising revelation was the Great Dark Spot's impermanence. Voyager-2 had captured it at just the right moment in Neptune's history. When the Hubble Space Telescope turned its gaze to Neptune only a few years later, the Great Dark Spot had vanished, erased from the atmosphere as if it had never existed. New dark spots appeared elsewhere, only to fade away in turn. Unlike the centuries-old Great Red Spot on Jupiter, Neptune's storms were revealed to be transient, forming and dispersing over periods of just a few years. This discovery forced scientists to rethink their models of planetary weather. If such massive storms could appear and disappear so quickly, what forces were driving their formation? Voyager-2's measurements indicated that Neptune's atmosphere, though frigid by earthly standards, was anything but static. Deep within the planet, residual heat left over from its formation rises toward the surface, fueling complex patterns of convection and turbulence. The interplay between this internal heat, rapid planetary rotation, and the chemistry of methane and other gases creates a playground for storms of unimaginable intensity. Beyond the Great Dark Spot, Voyager-2's data painted a picture of Neptune as a world of extremes. The spacecraft documented other smaller storms, high-altitude clouds racing around the equator, and an atmosphere layered with intricate bands and zones. It detected a faint but dynamic ring system and captured images of Neptune's largest moon, Triton, revealing geysers of nitrogen gas. But it was the Great Dark Spot, with its fleeting existence and formidable power, that captured the imagination of scientists and the public alike. Voyager-2's close encounter with Neptune remains to this day the only time humanity has visited the blue giant up close. The data and images it returned continue to serve as a foundation for astronomers seeking to unlock the secrets of planetary atmospheres both in our solar system and beyond. Voyager-2's historic passage through the Neptunian system was much more than a fleeting encounter. It was a revelation that fundamentally altered our understanding of planetary weather, not just within our own solar system, but across the universe. As the spacecraft raced past Neptune's cloud tops, its suite of scientific instruments captured an astonishing level of detail. The Great Dark Spot, that enigmatic vortex nearly the size of Earth, was revealed as a dynamic, swirling tempest, bordered by the fastest winds in the solar system. Those winds, clocking in at over 2,100 kilometers per hour, puzzled scientists. How could a planet so far from the Sun, receiving only a fraction of the solar energy that warms Jupiter or Saturn, generate such ferocious atmospheric activity? Voyager-2's data suggested that Neptune's internal heat, left over from the planet's formation, fuels convective currents and drives these violent storms. This was a critical clue. Even at the edge of the solar system, planets could possess enough internal energy to power breathtaking meteorological phenomena. Close-up images showed that the Great Dark Spot was not a simple blemish on Neptune's face. Instead, it was a towering vortex, ringed by bright white clouds made of methane ice, high-altitude formations casting shadows onto the deeper, darker layers below. The contrast between these icy clouds and the storm's core made the Great Dark Spot stand out so vividly in Voyager-2's images. For planetary scientists, this was the first ever chance to study a storm system on an ice giant up close, revealing a new class of atmospheric phenomena distinct from anything seen on Jupiter or Saturn. One of the most surprising discoveries was the temporary nature of the Great Dark Spot. While Jupiter's Great Red Spot has raged for centuries, Neptune's GDS appeared, shifted, and vanished within less than a decade. When the Hubble Space Telescope turned its gaze toward Neptune in the 1990s, the Great Dark Spot had completely disappeared, its once imposing presence erased by the planet's tumultuous winds. Later observations revealed that new dark spots could materialize elsewhere on Neptune, demonstrating that these colossal storms are transient, shaped, and destroyed by the ever-shifting wind patterns around the planet's atmosphere. This dynamic behavior fundamentally challenged previous models of storm formation on giant planets. Voyager-2's observations revealed that the most intense winds actually circled the edges of the Great Dark Spot, forming powerful jet streams that confined and maintained the storm's structure. This insight was vital for understanding not only Neptune, but also the weather systems of other gas and ice giants, and even the atmospheres of exoplanets orbiting distant stars. The legacy of Voyager-2's flyby extends far beyond Neptune itself. The data collected on that August day in 1989 has been repeatedly reanalyzed, forming the baseline for all subsequent studies of Neptune's atmosphere. Every new observation by Earth-based telescopes or the Hubble Space Telescope is interpreted in the context of Voyager's discoveries. Scientists have learned that the mechanisms driving Neptune's storms, internal heat, complex atmospheric chemistry, and high-speed winds may be common among gas giants throughout the galaxy. These findings shape how we search for and interpret weather patterns on exoplanets, broadening our understanding of planetary systems everywhere. Moreover, Voyager-2's images of Neptune and its great dark spot have become iconic, inspiring generations of scientists and enthusiasts alike. The flyby demonstrated that even with a single visit, a spacecraft can unveil the secrets of a distant world, transforming it from a blurry point of light into a dynamic, evolving planet. Neptune's storms, its shimmering blue clouds, and the transient beauty of the Great Dark Spot serve as a reminder of how much there is still to discover in our solar system. As we look to the future, the enduring data from Voyager-2 continues to inform the design of new missions. Proposals for future orbiters and probes to Neptune build directly upon the mysteries that Voyager uncovered. Scientists hope to one day return to the blue giant, perhaps with a spacecraft that can linger in orbit, mapping its storms and probing its deep atmosphere in even greater detail. Every new mission will owe a debt to Voyager-2, the trailblazer that first revealed the true nature of Neptune's wild weather. Until that day comes, every view of Neptune, through telescopes, spacecraft, or the lens of science fiction, carries the legacy of Voyager-2's journey. The Great Dark Spot may have vanished, but the questions it raised and the discoveries it sparked continue to ripple through the field of planetary science. As we push further into the cosmos, seeking new worlds and new mysteries, the story of Neptune and its fleeting storm stands as a testament to the power of exploration. Thanks for joining us on this voyage to the outer reaches of our solar system. If you enjoyed exploring the mysteries of Neptune, make sure to like this video and subscribe for more content like this.